Hi again, here's the question. It's a little bit tricky, but I'm sure you could do it. So try it out and then watch what I'm gonna do. So just pause the video there for a second and watch what I'm gonna do. I mean, just pause the video, do it on your own, and then come back and see what I've done to see how you get the answer. Okay, so cos to the 4x minus sine to the 4x equals 1. Then 1 minus 2 sine squared x would equal what? So what I'm going to do to this, I'm going to take this, the cos to the power of 4x minus sine to the 4x, and I'm going to factor this, of course, equals 1. When you factor this, you're going to get cos squared x minus sine squared x, difference of squares, times cos squared x plus sine squared x, and all of that equals 1. Now, cos squared plus sine squared from your Pythagorean identity, when you add cos squared plus sine squared, you know you get 1. So all of this just equals 1. So what I end up with cos squared x minus sine squared x equals 1. And now, if you know what cos squared x minus sine squared x is, this is the double angle identity, which is the cos 2x also cos 2x could be expressed as 1 minus 2 sine squared x. So cos squared minus sine squared is also 1 minus 2 sine squared x equals 1. So therefore, this one here would also equal 1. And that's what the answer for 1 minus 2 sine squared x is going to be 1. Okay. They could add to this question and say, you know, find x where x is between 0 and 2 pi. So that's your domain. If that's the case, you could either work from here or work from there. So I'll work from here. So you know how, as I said, cos squared minus sine squared x equals 1. Then that could be converted to cos 2x. So now I could just say cos 2x equals 1. And now, if you, as I said before, if cos x or sine x, both of them equal plus or minus 1 or 0, I always resort to the cosine wave or the sine wave. Here I'm going to resort to the cosine wave. So I'm just going to put that in here, right here. So the cosine wave goes all the way to 2 pi for a full period, pi over 2, 3 pi over 2. Now it starts at 1. So you get this, 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 and this, and then it's a wave like that. So if you look at where does the cos equal 1 between 0 and 2 pi, it equals 1 at 0, and also it equals that at 2 pi. So therefore, 2x here would equal 0 and 2 pi. Because remember, the angle here is not x, it's 2x. So instead of saying x, you have to write 2x there. And then you could divide both sides by 2, divide this by 2, divide this by 2, and then you'll get x equals 0 and pi. Yeah. So these are the two answers that you have. You know, the period for this would be, period here would be pi. So if you want to find the other answers, you have to add pi to both of these answers here. If you add 0 to pi, you're going to get pi anyways. But if you add pi to pi, you're going to get 2 pi. And since 2 pi is not in the domain, then this is the answer for this. It's between 0 and 2 pi. You have only two answers, which x equals 0 and pi for cos 2x equals 1. Now, if you want to even look at it and see how, you could graph that cos 2x between 0 and 2 pi. So if I'm graphing that between 0 and 2 pi, you remember how we said the period becomes pi. So if I use a different color to just graph a cosine graph, like if we're graphing y equals cos 2x, then the period here is pi, because the period has been condensed by a half, since we have a horizontal compression by a half. So therefore, my full wave, this wave would be between 0 and 2 pi. So you'll get something like this right here. And then it will repeat. And it goes right there. Sorry, that should have been more like this. Yeah. Yeah. Now, again, as I mentioned, cos 2x equals 1 would be right here and right there, and also right there. But since this is not in the domain, then it's not part of the solution. And that's just another way of looking at it. Yeah, and this is it for this question. As always, thanks for watching. Bye-bye.